Okay, so year 9 we were looking at this problem last week of the patterns in this sequence of shapes. So we had shape number 1, 2, 3. Hopefully you were able to draw shape number 4. Here's a quick sketch. So that'll be shape number 4. Describe any patterns you found. So a description of some patterns we found. Well, you can add 2 squares and 1 triangle for every shape. You could also say we add 3 additional shapes each time, so not specifying whether they are triangles or squares. So the total shapes increases by 3 each time. You could have said anything like that would have been correct. Where there are 6 triangles, how many squares are there? So that's noticing a pattern. That's why this table is so important. The triangles are increasing by 1 each time. So 2, 3, 4. This is the 4th shape. There's 4 triangles. The squares are increasing by 2 each time. So for this particular thing, you should notice that the pattern, how many squares are there? If there's 6, well, you can relate it directly to the number of triangles. You can notice a pattern. The formula for triangles to squares would be double. You double the number of triangles and you get the number of squares. So if we have 6 triangles, we then have 12 squares. Draw a picture to show the pattern. Draw a table to show the pattern. So this is the table that you should have copied. Total number of shapes is going to be asked pretty soon. So adding these 2 numbers is going to be total number of shapes. So you should have this. Okay, so 3 plus 6 is 9. You can also count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay. Part 2 then. Where there are 24 triangles, how many squares are there and how do you know? 25 triangles. So 25 triangles is the same pattern again. Doubling. So if there was a 25th triangle, it would have 50 squares. How did I know this? Well, I noticed in my pattern that it was doubling, something like that, saying double the number of squares than triangles in each shape. When there are 8 triangles, how many shapes are there in total? So that's relating this triangle number to the total number down at the end. So what relationship does 1 have to 3, 2 have to 6, 3 have to 9, 4 have to 12? Well, each one of those is multiplied by 3. The triangle number is multiplied by 3. So, if I wanted to find this without having to draw them all out, 8 triangles would have 24 total shapes. Question 6. Where there are 40 triangles, how many shapes, squares and triangles are there in total? So 40. So we still use that formula of multiplying by 3. So 40 by 3 would be 120. How did I know this? Well, I noticed a pattern that there's 3 times as many total shapes as there was triangles. Part 3. If you have a picture with T triangles, write a formula to express the number of squares. So this was here. So the number of squares, S, is going to be twice T, 2 times T. Of course, if we're skilled algebraic figures, we should not have that multiplication sign because that looks too much like an X. So we would just call it S is equal to T, and that will be a formula. Total number of shapes, so I call total number of shapes X. So X related only to T, so saying T plus S would not, triangles plus squares would not work in this case. You can only relate it to T, it only asks for it in terms of T. So in terms of T, we noticed the pattern was 3 times T. That would be a formula relating the total number of shapes to triangles. Test your formula. Okay, so a test would be, let's test this formula, S equals 2 times T. Well, let's test it for the 3rd shape. So twice the number of triangles. So there's 3 triangles here. Twice that, and that is 6. Oh yeah, it worked. Question 9. Justify a formula when it works for any picture of the sequence. So justifying the formula that works for any picture of the sequence, you can see there's a constant jump plus 2 squares each time and plus 1 triangle. So once you've tested it and say something about you notice that for every 2 squares there's 1 triangle, that'll be enough to justify this formula because it's quite simple. Question 10. Can there be a picture with 119 squares? Justify. Well, 119 squares. Now I look at my pattern of squares. 2, 4, 6, 8, 10, 12, 14, 16. What are those numbers? They're even numbers. They all can be divisible by 2. So can 119 be divisible by 2? Well, it can, but it will not give you a whole number. And that means that it wouldn't be part of this pattern. So 2 into 119 goes, testing error. So 60 would be 120, so it's going to be 59.5. So that 0.5 rules it out as a sequence because they have to be whole numbers in the sequence. There is no 59th and a half in the sequence. So something like that would be a correct answer. Can there be a picture with 1,923 shapes in total? 1,923 shapes in total. Could be if it's divisible by 3, because the total number of shapes goes up in 3s. 3, 6, 9, 12. So if that number is divisible by 3, which we can test, 1, 9, 2, 3. Of course, there's a quick way to test if something's divisible by 3. You may know this. Adding up the digits, 1 plus 9 is 10, plus 2 is 12, plus 3 is 15. That looks like it's going to be divisible by 3, but let's just double check. 3 into 1 doesn't go, 3 into 19 will go 6 times the remainder of 1. 3 into 12 goes 4, and 3 into 3 goes once. Of course, you can do that in a calculator if you want, but it is the 641st term. So the 641st term would have 641 triangles, because remember the triangles go up in 1, and it would have double that number of squares. So it would have, what's that? 1,282 squares. So triangles for this one would be 6.1. Squares for this one would be 1, 2, 8, 2. Last question then. Can there be a picture with 7,832 shapes in total? Well, that's, once again, it's the same problem. So 7,832. Once again, if I divide by 3, it goes in twice. Once, 6, once, and then 2, 3 into 2, no, it doesn't go. So we're left with 0.66, I think, recurring. So no, there will not be a shape because there is no such thing as a third shape with a third in it, or 2/3 in this case. Okay, and the final question I asked was how many matches in the 937 shapes? So if you watched the video, you would have got this question. So let's look at the matchstick pattern. How many matches are in the next shape? Well, this is trickier. There's 8 in the first shape, many's in the next shape. Well, I've added 1, 2, 3, 4, 5, 6, 7. I've added 7, not 8 more, because these two are in both shapes. They're not added on. Okay, it's actually 9, isn't there? There's 9 in the first shape. My mistake. Because these two are constant. These first two are constant. So there's 9 in the first shape. My mistake. I added on 7, so that gives me 16 matches. Let's just test that I add on 7 next time again. 1, 2, 3, 4, 5, 6, 7. Yeah, I've added on 7 again, so it's 23. I continue that pattern. I'm at 30. Okay, so this is my pattern. Not as simple a pattern, but I can see I'm adding 7. If I'm adding 7 in a pattern, that means it's a multiple of 7 in the formula. It's going to be 7 times the number of triangles. And then, but 7 times t, for instance, for this one, 7 times 2 gives 14, not 16. 7 times 3 gives 21, not 23. So I'm 2 away. This formula will get me the number of matches. That's one way to do it. So if I know my formula, 7t plus 2, I can just use my calculator for the 937 shape. So it'll be 7 times 937, and then add 2, 6, 5, 6, 1. Shapes, matchsticks in the 937 shape. Now, if you took my word for it and put 8 here, which is a mistake by me, you wouldn't have got that. Okay. All right, so that's all the questions there on that particular worksheet. So Ms. Williams is going to help you with the problem solving, and good luck with that.